Hello students, in the last class we have derived an expression for the error for trapezoidal rule. Today we will be doing the same thing but for Simpson's 1/3 rule. Okay, so our starting point will remain the same. That means we will start from the quadrature formula. Okay, so let me make it closer for you. So this is your quadrature formula, right? So what I have told in the class, for Simpson's 1/3 rule, we should consider n equal to 2. What is this n? Number of subintervals. Okay, so in trapezoidal case, we have taken one chunk of an area, right? So for this case, since n equal to 2, so there will be 2 subintervals. So that means there will be 3 points. So 1, 2 and 3. This is basically x0. This is basically your x1 and this the last point will be your x2. Fine. So if we already know that x1 is basically x0 plus h, then what will be my x2? X2 will be x1 plus h. Now what is x1? It's x0 plus h. So x0 plus this distance h plus this distance h. So x0 plus 2h. Okay, x0 plus 2h. Fine. So we are considering only 3 points here. That means n equal to 2. Fine. So now put n equal to 2 in this equation. What will happen? This term will be there, this term will be there, and this term will be there. The delta q term will not be there. Why? Because for delta q y0, we need 2 delta square y0. But in this case, we will see if you make a difference table, you will get only 1 del square y0 term. So delta q y0 is not possible. Okay. So we are considering only first term, second term and the third term. Okay. So if you put n equal to 2, so this will be 2y0 plus 2 square by 2 del y0 plus 2 into 2 cube minus 3 2 square by 12 and del square y0. Fine. So now if you solve this one, if you simplify this one, you will get this. Okay, and put for this del y0, put y1 minus y0, and for del square y0, you will put del y1 minus del y0. Del y1 minus del y0 will be del square y0. So if you put that, you will get this term. Okay. So this is basically your Simpson's rule. So 1/3 rule. Basically simply Simpson's 1/3 rule. So if you don't understand this point, how this is, you are getting from this to this. So put, I told you, I am repeating once again, put del y0 is equal to y1 minus y0. And for this one, del square y0, it is del y1 minus del y0. Okay, then you convert it to y1 y terms, simply y terms, and then you just solve this, simplify this, you will get this one. Okay, now the procedure will remain the same. x0 is basically your fx0, y1 will be your fx0 plus h, and y2 is fx0 plus 2h. Now what we need to do for these two terms, for this and for this, we need to expand by Taylor's theorem. Okay, expand by Taylor's theorem. Just a minute, I'll put it back so that I can make it clear for you. See, so we need to expand this one and this one. Fine. So if you expand this one, we will get this. So we are considering 1, 2, 3, 4, 5, 6. 6 terms. Why 6 terms? Later I will clarify that. Why I have taken 6 terms. Okay. Now if we expand this one, you will get this. This. Again I have considered 6 terms. Fine. So this is basically, instead of h, we are just put 2h in the Taylor series. You will get this one. And if you simplify this, you will get these terms. Okay. So total we are getting this. Fine. Now see, there is fx0 here, this is fx0 here, this is fx0 here. And this is h by 3, this is 4, and this multiplier is 1. Okay. So if you simplify this, you will get this. Only 2h fx 0. Fine. 2y fx 0. Only this term. Then for the other cases, for the other terms, you will get this one and this one. Okay. Now keep it as it is. So I have just find out an expression for is. S for Simpson. Okay. Similarly, here, for the earlier case, we have found out it, right? Same thing, I found it, I have written is. Since this is for Simpson's 1/3 rule. Fine. Now let's come back and find the error. What is error? Error is basically this integration from a to b fx dx, and for this case, it is not it, it should be is, right? Because we are finding for Simpson's 1/3 rule. Fine. So the procedure is again same. We are considering fx to be continuous, finite, and it possesses all the derivatives of all orders. Fine. And we are considering a capital Fx, which is given by the relationship between fx and capital Fx is basically this one. Okay. So we are trying to integrate now. What is my integration point? Since we have considered only 3 points. So first one will be x0, and the last one, that is the last one, will be b. That is, b is our x0 plus 2h. This is our limit from a to b. Right? Now I can write this one. If you integrate this one, what will happen? You will get this one like the earlier case. In the earlier case, we got f x0 plus h. In trapezoidal case I am talking about, and fx0. But for this case, we are getting f x0 plus 2h, because our limit is up to 2h, and minus fx0. Fine. Then similarly again, there is f x0 plus 2h. Wherever you find these terms x0 plus 2h, x0 plus h, or x0 plus 3h, simply expand by Taylor's theorem. Okay. Don't play with this one. No need to play with this one. Okay. So if you expand it and if you simplify, you will get this. Just remember, we need to convert capital F to small f term. Okay. If you don't understand this step, just take out a pen and paper and expand this one. Okay. And try to map this. I told you in the last class that one order of derivative will be decreasing if I convert from f to capital F to small f. Okay. So expand it and just write in terms of small f. You will get this. Okay. So this is basically our this term. This. Okay. Now what you need to do, just subtract. Subtract this whole thing with this one, Okay, you will find all terms will get cancelled out. This term will cancel out, this term will cancel out. Okay, this term will cancel out, this term will cancel out. The first term you will get in the error term is this one. So this term and this term will be our first term in the error expression. Okay, neglecting the higher order terms, that means from 6, 7, 8 we are neglecting. So first term we are considering only the first term. So it's basically not equal to, it is almost, we are approximating, truncating actually. Fine. So this is your error term. So if you simplify this, you will get minus h5 by 90 f4x. Fine. So basically this is your total derivation. Now you can do one thing, you can replace this h, by b and a. Do you know what is the relation between b, a and h? What is h? See, h is basically b minus a by n, right? B minus a by n. So for this case n equal to 2. So I can replace h by b minus a by 2. So if you can do this one. You can put this. Okay. You can put this. Instead of h, write b minus a by 2 whole to the power 5 90. So you will get b minus a whole to the power 5 minus, minus term will be there, by 2880. Okay, so I am writing the final expression here. Es is equal to minus b minus a whole 5 by 2880 f 4 x h4. You can replace x by any small term zeta which lies between x0 and x2. Okay, so this is your final error expression. Okay, so remember the order is basically this 5, this h to the power 5, this. Okay, so in the last class we have derived an expression for trapezoidal rule, and for this case for today's class we have derived an error expression for Simpson's 1/3 rule. These two derivations may come in the exam, so I have discussed here. Okay, just take out a pen and paper and do it. Okay, if you find any difficulty in solving, okay, let me know. I will help you out. Okay.